This is our robot chicken, cheese edition.
Last season, we learned a lot about robot design. In the off-season, we redesigned Chicken to have a more cube-like design, with the hub between the wheels at the center of gravity. This cube-like design allows us to easily place and remove attachments from Chicken. During the season, we found a problem with our robot design, specifically the wheels. The wheels that we originally used were not stable, had bad traction, and got dirty very quickly. As a solution to this, we decided to use more stable wheels that did not get dirty as quickly. In our latest version of Chicken, we moved the wheels to the back for more efficiency and reliability, and we also replaced the front wheels from wobbly blue wheels to bigger, thicker wheels.
We have a quick attachment system consisting of 2 gears at the top of Chicken where we can attach most of our attachments. This allows us to attach our attachments quickly and with more effectiveness. We also sometimes took inspiration from sources like YouTube to help us come up with new and innovative ideas.
This is the attachment that we used to complete the Raise the Mast mission. It's one of the most unique attachments because of how it works. It originally had a less stable frame, so we decided to give it a rework by giving it a more stable frame and making it so that it grabs the treasure chest every time.
We created a cradle or jig in order to make sure that Chicken starts in the right position for each mission. This ensures for whenever a team member had to miss the competition, everyone else would know where to position the Chicken, so it works every time. During scrimmage, judges liked that we used a cradle and gave us a suggestion that we should make it easier and more stable to use, which we have incorporated into our design. We also duplicated the cradle and created it for the other side. We also made a specialty cradle, which works for the artificial habitat and traveling for the other side of the board.
We decided to split our 4 dedicated coders into 2 groups, with each group focusing on one side of the board. Each group first started working on missions close to their home area, and then branched out to be able to string multiple missions together.
We opted to use Python as we felt this was easier to control and gave us more flexibility in block code. We focused on what was needed to complete a mission. We used comments to remind ourselves and others about what the code did.
We used pair programming, where one person was the driver or navigator, and the driver or programmer, and the other was the navigator. Then we swapped. The driver could debug code, call out, and make notes about where it was going wrong, then work together to correct any issues.
Chicken has been designed to be easy to use with the appropriate fire names in order to minimize start time. We did have a problem where Chicken would die mid-route, so we added a function to code to reset the motors.
We researched different ways to build attachments to use for as many missions as possible. One example of this is our arm, which we use for 3 different missions: the send over to submersible missions, changing ship lanes, and seabed sample missions.
Teamwork was a big part of our design, with each team member having different strengths. During each meeting, the coders and robot designers gave each other feedback on what needed to be changed, which we then incorporated into our design. We came up with ideas together to come up with our attachments.
We have an office portal which we use to share our documents, ideas, and innovations. We used GitHub to save versions of our code.
At the start of the week, we completed a robot maintenance log where things like checking wheels, checking motors, and checking attachments, cleaning wheels, and checking motors were logged. We also went through each attachment in order to make sure none of them broke or got loose to the point of no longer functioning. This helped identify any issues before they became more of a problem.
Future developments. In the future, we would like to use external sensors. We tried, but we found our lighting affected the sensors that use light to move. We have started to research the use of these and being able to calibrate them so they can work in most lighting. This would really help our robot with consistency, including any map defects.
During our Friday sessions, after we finish coding and working on the project, we have a little fun by eating pizza and playing games. We also go to CC's at the end of the FOL season as a celebration.
Thank you for listening. Any questions?